Okay, let's go ahead and get started. So welcome to our workshop. Glad you're here. I enjoy this one a lot. My name is Erik Gross. I will be your presenter this evening or this morning if you are in another time zone completely, right? I'm a senior level software engineer, developer, architect. I've been programming computers since I was 11 years old, which is a long time ago. I'm also a Navy veteran. I was in the Navy as a nuclear reactor operator and electronics technician, and that's where I found out that I like teaching. Um, I didn't plan on it. I was told to do it. In the Navy, you pretty much do what you're told. All right, give me just a second. Apparently, I'm doing the wrong class. Give me a moment and look at the class. Give me a moment to get scheduled, to get everything straight here. All right, today's the 17th. Yeah, Gracie, take a look at the schedule. I've got pros and cons of working in tech today. If I've got that wrong, then I will grab the other presentation. Oh, good. Awesome. That's fine. I love this one. Okay. Actually, let me know in chat. Um, did you come to this class tonight thinking you were going to do a free JavaScript class or a pros and cons of working in tech class? Drop it in chat and let me know what you were signing up for. JavaScript. Awesome. Okay, good. All right, I've got that ready. There's just some administrative confusion on my part, and I apologize. Okay, we're going to do JavaScript tonight. Good. I like writing code. I've been writing a lot of code recently, building some really funky custom programs related to a retail business, which has been kind of fun. Okay, good. So yeah, back to introduction. Like I said, I've got Navy experience. I'm also the co-founder of the Tech Academy, the school that puts on these free classes. So I'm really glad to be here, and I'm glad we're able to switch so quickly and get me the right material. So thank you for that. Okay. And by the way, the person who is so awesome about catching that is our assistant, Gracie, who you'll probably see in the chat. She's there to monitor the whole meeting, help me with things like this, answer questions, remove problematic people, although that rarely happens. So she's there to help. I think you all know how to use chat, okay? And if you are just now joining us and have not dropped into chat to let me know where you're joining us from, please do so. Oh, I got people from Orlando. That's excellent. Another place I lived. That's where I went to boot camp when I was in the Navy. I'm in Slidell, Louisiana. That's near New Orleans. We're getting ready for Mardi Gras down here, which is the biggest party I've ever seen. We got people joining us from Massachusetts, Los Angeles. Oh, Ali, I hope you're doing okay down there. I've got a lot of friends in LA, and I've been praying for them and thinking about them a lot because it's quite the ordeal they're going through. I hope you're okay. All right, good. So let's keep moving forward. Basic agenda. We'll have a short explanation of the Tech Academy, who and what we are. Then we'll do our workshop. We're going to be building code in JavaScript. I try to monitor the chat during the coding session to catch any questions as we go. But if there's anything I've missed and we have time, I'll do a brief Q&A session right after the workshop. We'll then go over some information about our boot camps, how we help people break into tech. There is a free gift for you at the end, so please stick around until then. I think you'll really like it. The whole class should take about an hour to an hour and a half. So a brief note on the Tech Academy. Who are we? Well, we provide coding boot camps. We do a lot of stuff in technology, but primary thing we're known for is boot camps. If you're not yet familiar with boot camps, they've only been around for about a dozen years. They are pretty popular around the world. They are intensive technology certification programs, and what they're really designed for is to help prepare people for entry-level positions in tech. It's one of the three ways that you can break into technology. You know, college, self-taught, or boot camps. That's how to break into tech, right? Most boot camps typically last 3 to 6 months. They focus on practical, modern skills, often in a way that college classes can't for a lot of reasons. At the Tech Academy, we've been offering thorough, budget-friendly, flexible, trusted boot camps for well over a decade. In fact, we just passed our 11-year anniversary, I think a couple of days ago, around the 14th. And our programs are cost effective. They're self-paced, which is kind of unique, right? They're fully online and they're tailored for absolute beginners, people who have no prior technical or coding knowledge, right? Quick survey, actually. Do me a favor and drop into chat and tell me a yes or no. Are you a beginner to coding? Yes or no? Are you a beginner? Would you classify yourself? Got a bunch of yeses, got a few nos. Beginner with some experience. Another beginner, a little bit of a no. I like this. Ish, mostly yes. That's really good. Okay, good. Awesome. All right, good. Now, before we go any farther, actually, for those of you who already have some experience coding, I believe you're going to get a lot out of today's class, especially in terms of some fundamental principles that you can use to rapidly advance the skills you already have in programming. And if you're brand new to it, it's the perfect introduction. Back to our, like I said, they're for absolute beginners, right? Cover really in-demand skills. The programs are endorsed by really awesome online reviews, and they're really flexible. They're designed to fit around your personal schedule, and we like to prepare people for a technology career with what we consider to be a really well-rounded toolkit. We don't just teach you one thing. There's a number of aspects to it. Boot camps around the country, at least here in America, they average around $13,500. That's 2024 pricing. And our boot camps are priced well underneath that, under that national average. In fact, we have boot camps that start as low as $59.80. And the last thing I want to say right here is just what our mission statement is. Like, why do we do what we do, right? And my co-founder and I came up with this a dozen years ago, and it still stands today. The mission of the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. So that's our mission. Our product is you working in tech. Now, some class expectations, right? What this class is and isn't. We are going to provide simple definitions for technical terms. We'll cover technology-related concepts in plain English. There'll be coding, right? And one thing about that coding, by the way, this is the wrong slide deck on this slide alone because I got the class wrong at the beginning. In terms of the coding, just a little bit of a like heads up on it. It's challenging sometimes, especially, you know, we have a bunch of people that are beginners here. We've tried to make this class as easy as possible for absolute beginners, and it is, right? But even given that, when you're writing code, especially for the first time, it's important to do a couple things. One is to write the code that I'm going to share with you exactly as it's written. And the reason for this is when you're writing code, sometimes the most seemingly minor thing, like a missing comma or semicolon, or a word that's capitalized when it shouldn't be, they can cause your code not to work, right? So when we're typing the code, just pay close attention to what I'm typing. I'll go slow and type it exactly as I wrote it down. And finally, make sure you're in a distraction-free environment. It's really critical. There's a lot to learn, and I'd like you to be able to put as much attention on it as possible. There we go. Let me go ahead and switch over to the actual correct slide deck here. Give me just a moment. All right, here we go. So, introduction to JavaScript. Okay. We're going to cover a couple of fundamental terms first. And the first word I want to cover is just what exactly is a program. Now, we've used programs all the time. On your computer, you are probably using 10 to 15 different programs right now. The browser that you're using to access this this class is a program, and you used probably word processing programs or games or all kinds of things. These are all programs. Here's what's different, and there's a kind of a shift to happen in your mind in a coding class. You're going to be the one creating the program instead of just using it as a consumer, right? But a program is pretty simple. It's just a set of written instructions that you can enter into a computer, and it makes the computer do things. You're going to be creating those, okay? The instructions you write are written in a programming language, and it's just like it says here, it's just a set of words, phrases, and symbols that if you enter it into a computer, you can make the computer do what you want it to. That's how we make computer programs. And finally, there's the term coding. This is an action of actually just entering in those instructions. That's what coding means. Typically, it looks pretty simple. You just have a text document open and you're typing in these words, phrases, and symbols. And then you feed them into the computer and the computer does what you want to. Or sometimes the computer doesn't do what you want to and you have to figure out why, which is a lot of fun. So just some basic terms, right? Now, specific to this class, let's cover some terms related to JavaScript, right? JavaScript is a really popular programming language. If you've looked into the technology world at all, you've probably heard of JavaScript, right? It's been around for, at this point, 30 years. And you can use it to add really cool functionality to websites. You can also use it to just write full-blown programs, stuff that can operate outside of, websites and browsers. So JavaScript's very versatile. There's another related technology. It's called HTML. That stands for Hypertext Markup Language. Now, there's a lot to break down there. We'll keep it really simple. It's just a language that can describe what a web page looks like. What's the content on it? How does that content appear? That's what you use HTML for. We're not going to go deep into HTML, but you're going to see some of it tonight. And so I want you to know about it, okay? And then finally, a third related technology is called CSS. It stands for Cascading Style Sheets. And this is a really cool technology you can use when you have a website that has lots of pages on it, because you've been to websites that have a whole bunch of pages, right? This is a technology or a language you can use to control the appearance of all those things on the website. You might, for example, make it so that every image that's shown in a website has a nice little border around it. And you can change, what does that border look like or what color it is. You could change what's the font that everything appears in based on what it's representing. You can change the way tables appear. All of these things can be changed in CSS. And the cool thing is the way the cascading style sheets part of it, that cascading thing, the way that works is you can make a change in one place with CSS and that change ripples out or cascades and changes the way everything works across your entire website. So it gives you a lot of control as someone who makes websites. So these three technologies here, they all kind of work together if you're doing web development. And so we wanted to cover what the basic definitions of these terms are, okay? This is a JavaScript class, and so you're going to code in JavaScript, but you'll see some of this HTML and CSS. Now, this next slide is, without exaggeration, the most important slide of the entire night. I talked to you about the idea that if you've already got some experience coding, that there's going to be some really things you might learn. I would put forth the idea that what we're going to cover on this slide is one of those most important things, cool things you can learn. And here's what it relates to. Any computer program is only ever made up of 5 basic elements, and that's it. That's all that's inside any computer program. If you start to understand what these 5 things are and how they work, if you're already coding, it can go a lot better for you. And if you haven't really coded a lot, it's, like I said, the perfect way to start. So let's talk about these 5 basic elements of any computer program, beginning with the first element, which is the entrance, also called an entrance point. All this really means is that any computer program has to have a first instruction. You know how you start a program on your computer, usually you'll find a little icon that represents the program and you'll double click on it, right? When you do that double click, here's what happens precisely. The program has a first instruction, and that first instruction goes into your computer, and the computer executes that first instruction. And then it goes on to the next one, and the next one, and the next one, which probably might sound like a pretty straightforward concept, and it is. But here's why it's important. Without getting into a bunch of really nerdy stuff about what's inside your computer, like the actual physical computer, like right here, there's the tower on my desk, right? Without getting into a bunch of really nerdy stuff, there's a couple fundamental things that you need to think with here. When a computer program is operating, when it's running inside your computer, it needs to be able to work with data. In fact, the basic purpose of a computer is to take in data, work with that data in some way, some manner, and then send data on somewhere else. That's the purpose of a computer. Take in data, process it, and send it somewhere else. So your computer has to work with a lot of data, right? Well, one of the things that's built inside computers is a place to store that data that's being worked with. They're called memory storage devices. They're physical devices, and you may have seen them actually, right? They're little sticks. They're called RAM, and they're maybe 3 or 4 inches long. And if you ever take off the case of a computer, you can see them stuck inside the computer. And what's on those little devices, it's actually pretty amazing, are tiny little teeny electronic circuits that can hold data for you. In fact, on one of these little teeny sticks of RAM, 3 or 4 inches long, there might be 3 or 4 billion little teeny locations where you can store data. Computers work with a lot of data, right? Why do we care about this? Well, here's why. You only have a certain number of these devices in your computer. You might have a little bit, you might have a lot, but there's only so much there. And so when you start up a computer program, you need to do something really important. You need to go inside those devices and reserve a certain number of those locations to store data. They call it memory locations. You need to reserve those and say, these locations are only for use in this computer program that just started up. Don't let any other programs that are running on the computer into those locations, because you don't want to mess up that data. It's a pretty important step when you start a program. And so part of the reason that this entrance point is so important is that's what, when that instruction gets performed, that's what tells the computer, hey, please go ahead and reserve some memory location for this computer program that's about to run. So that's a pretty important thing to happen. But you don't see all that happen, okay? And as a programmer, you kind of just know it happens and it doesn't really change your life very much. Here's another aspect of this element, this first instruction element of a program that actually can affect your life and can help you a lot. Picture this. You just got your first technology job. Yay, that's awesome. You get assigned, you're on a team, you get assigned on a team, and you find out that team is responsible, say, for a really big existing computer program that lots of people have worked on over the years, right? And you're like, okay, wow, I have a lot to learn here. One of the first things you want to do is figure out, okay, what is this program all about? How does it work? It's got a lot of moving parts. Knowing that every program has an entrance point, it has a first instruction, you know that with certainty. Well, then what you would do is you'd find in this big giant program, where's the first instruction that gets performed? And it's actually a pretty easy thing to find out. You can actually Google stuff like that. You can find out, hey, here's the kind of program I have. Here's the language it's written in. How do I find the first instruction that gets executed? And once you find that, it's like gold. The reason why is that if you're new to that program, you can look at that first instruction and understand what it does, and then go to the next one, and then to the next one. And you're going through and starting to understand this computer program the same way the computer executes it. The computer starts at the first instruction and keeps going forward from there. So you start that way. And it's so much easier to start to understand a really complex program when you approach it this way. There's a lot more I could say about that, but that's one of the reasons why this is one of the most important elements of a program. What's that first instruction? Second element that's really important is a thing called variables. Variables are just pieces of data that a computer is gonna use, and this is the important part, that can change while the program is running. It's information that can change. Think of like when you start a video game. I've been getting back into like old school Japanese RPGs, right? Things like Final Fantasy and that kind of stuff. And I started one up the other day, Final Fantasy 2. And when you start up the game, there's a certain point where you're given 4 pre-made characters to play inside the game, but you can change the name of the characters from the default names that are given. That's an example of a variable. From that point forward, that computer program has to keep track of the fact that this is a changed piece of data. So that's what a variable is all about, okay? Anthony, are you seeing my presentation, the 5 elements of a computer program? Do you guys see my slide deck? Okay, good. Yeah, other people are seeing it, Anthony. I'm not sure what's going on. It sounds like it's on your end. I apologize. So I'll reiterate so it'll be a bit easier for you. First of these 5 elements of a computer program is the entrance point. The second one that we're discussing now is variables. Oh, good. Excellent. Thanks, Anthony. Okay, good. So variables are super important. A computer program that can't keep track of data that can change is going to be not very valuable to people. Here's the next, element of a computer program that's really important. It's called control and branching. There's got to be a way inside a program to control whether or not a computer program takes one of 2 or more available courses of action. In other words, there's got to be a way for a computer program to make a decision. The best way to think of this is the construct if, then, else. This is a nice construct. If such and such is true, then do this. If not, do that. Look, we make decisions all the time, especially when we're dealing with data. Computers are no different. This is how they have to work. You have to build into your program a way for a computer program to make a decision. You have to give it the available data. You've got to give it the data that it can make a decision on. And then you have to tell it explicitly what to do based on the decision it made. We call the mechanism in the program to make the decision, we call that a control. You're controlling which way you're going to go. And we call the courses of action that you can take branches. Think of it like branches off of a tree, right? And you're going to build all this tonight. You're going to see it in code. But I just want to cover the concept first. Without control and branching mechanisms of some sort, your program is not very valuable. It's going to start from the top and just do a bunch of things, and it isn't going to be able to make any decisions about the data it works with. You have to have this in a program. The next of these 5 elements of a computer program that's so important is what are called sub-programs. Like it says, you can think of them as programs within programs. This is super, super valuable. Now, again, you're going to build one of these tonight. You're going to see how it works. But the basic concept is this. When you're writing a big, long program, and it's got a bunch of instructions, one after the other, there's a thing that can happen really, really often. And what it is that you'll find yourself as the programmer using the same set of identical instructions in the same exact order several different places in your program. Maybe it's something where you want to sort a bunch of numeric data from least to greatest or whatever. And you find a nice way to do that, and you keep doing that over and over and over again in your program. Well, having to write out those identical instructions over and over again is, first of all, time consuming. Second of all, it's really error prone. It's kind of easy to make a mistake and not do it 100% identical each time. But worse yet, if you want to go back and change the way you do those 5 identical steps, for example, you've got to go through your big giant program and find every single place that you were doing it the first way and change them to do it the new way. It makes it really, really hard to maintain your program. And so being able to create what are called subprograms is super valuable. And a subprogram is just, hey, let's take those steps that we're doing over and over again. We'll package them up almost like in a little box, and we'll give that box a name. We'll call it subprogram number 1. And then when you're writing your program, the big giant program, every time you need those exact set of instructions to happen, you don't type them all out. You just type, hey, go do subprogram number 1, please. And when you're done, come back and pick up where you left off. It's a really powerful element of a computer program. And again, frankly, it's one of the fundamental building blocks of a program. And then that takes us to our last element of a computer program, which is an exit. There needs to be a final instruction. There needs to be an instruction that says to the computer, hey, this program's done, it's over, it's no longer running. Now, that's important for a number of reasons, but the biggest one relates to the entrance point. Remember how I said that when you start up the program, the computer says, oh, okay, I'm going to reserve a bunch of the locations in these memory devices inside the computer. I'm going to reserve a bunch of them for this computer. Well, when you get all done running the program and that last instruction, that exit point gets reached, that also tells the computer, hey, you know how you were holding on to a bunch of those memory locations for this computer? You don't need to do that anymore. You can release those and make them available to other programs. It's a really important step to happen. So here on this screen, you see the 5 fundamental elements of any computer program. And again, there's no computer program written that's made up of anything besides these 5 things. That's what's in all of them. And so if you can start to think of that when you study computer programming, it gives you like a mental framework to think with. All right. Now, with all that said, let's go ahead and start writing some code. Doing some programming. We need a place to do that. You need an editor, a place to start writing out the instructions that are going to be fed into the computer to make it do stuff. We have an editor for you to use. It's online. And it's the link for that. Gracie just dropped it in chat. Go ahead and click on that link in chat. And what's going to open up is something that's going to look a bit like this on the right here. You're going to see one of your browser tabs in your browser is going to open up, and you're going to see that kind of an editor. I'll explain how it all works, okay, in a moment. But here's the first thing I need you to do. I want you to be able to see the code I write side by side with the code you're going to write. So if you've got 2 monitors, that's easy. You're just going to keep me and my Zoom window on one monitor and this code editor you just opened on the other monitor. If you don't have that, you're going to have to do it on one monitor. You're going to want them side by side. So I'd like you to take a moment and set it up so you have Zoom on the left-hand side. That's me, right? And the screen that I'm sharing. Put that on the left half of the screen. And on the right half of the screen, put this browser window that has the code editor. A little bit of help on that if it's being a real pain. If the Zoom meeting won't collapse down and be able to be moved around, you can sometimes click on the word Zoom meeting and then a restore button right there, and it'll collapse it a little bit and let you move it around and resize it. Same thing with the browser. Often in the top right corner is a little symbol. It looks like 2 squares. It'll let you resize. It's that one right there, okay? So I'm going to give everybody a minute to get everything resized and side by side, and then I'm going to jump into coding. All right. Now, again, a couple notes about the coding, okay? I'm going to give you the full code for a full JavaScript game here, okay? But we're not going to build out that entire game. That would take 3 or 4 hours, and you'd want to fall asleep, and it'd be way too much. Instead, here's what we're going to do. I'm going to show you how to build those 5 elements of a program in this language, JavaScript. We're going to use examples that would come up in the game, okay? But that's what, and then when we're done with all that, I'm going to show you the full code for the game, and we're going to go through it, and you'll be able to identify what a lot of the building blocks are and start to build some of your own stuff. So the first thing I'm going to do, let me stop sharing for a second. I'm going to get set up so I have the code editor. Gracie, I'm going to need you to send me there we go. You're awesome. Okay, let me share my screen again. Now, don't follow along now. What I'm going to show you the whole game, okay? Move some of my zoom controls around. So this is just a memory game is all we're dealing with here, okay? So we're going to show you it for a second, and then we're going to jump into some coding. So I'm going to guess this one, that's a heart, and this one, a spade, okay? I'm going to go this one, spade, there's a spade. Okay, I got a match. Do this one, heart, and this one. Okay, got a match. Here's a diamond. Nope. Do this one. There's the diamond. All right, and I got them all. So, and then something pops up and says, "You win. Play again." So that's what the game is. And again, here's all the code for it. We're gonna look at that in some detail in a little bit. Don't worry about that part right now. Okay. Here's what I want you to do. This is what you should have on your screen. Okay. Already. Is there anybody? Let me know in chat who does not have this code on the screen. Let me know in chat. Okay, now this code is the code for a web page. That's what this is. And that's why you see HTML in here. Now, I told you earlier, this isn't a class on HTML. We're not going to be designing web pages here. This is a class on JavaScript. Well, here's what's interesting. This web page, this code is for a web page, it has JavaScript in it. And the place it is right here. In between these two things that say script and /script, all of this is JavaScript. And in fact, if we run this, you'll see that we have the value of z is, that is being produced because of JavaScript code. That's what's happening here. So the first thing we're going to do is we're actually just going to get rid of all of that code. Now, look very closely. Only delete the part that I have highlighted. Don't delete any other element of what's on the screen. All right. So let's go ahead and start doing some programming. The first thing we're going to do is we're going to make something pop up on the screen that has text in it that we decided on. Now, you saw a little thing pop up earlier when I won the game. The way you do that is with a special JavaScript instruction called alert. So the first thing you want to do is type alert and then do 2 parentheses and a semicolon. And now this part's important. Go back inside those parentheses and do 2 double quotes. And then go back and put your cursor right inside those double quotes. And now let's make something that's going to print in this, this alert that pops up. Let's choose the classic hello world, exclamation point. And then go and run your program. And the alert pops up. If it didn't work, look closely at the exact thing I wrote and make sure you duplicate that character for character, letter for letter, everything's exactly the same. Now, you can click OK. And even on this one line of code, there's actually a lot to learn here. Here's the first thing. What is this word alert? Well, this is a JavaScript instruction. The people that designed the JavaScript language have a bunch of words and symbols and phrases in it that make up the language. One of those words is alert. Alert is what's called a function. It is an instruction that does some work. You saw the kind of work it does. What it does is it takes some content, the content that's right inside these double quotes. It takes that content and it makes it appear in a little pop-up box. That's the kind of work it does. But there's a couple things to look at here. Because this instruction alert is a function, it's probably going to need some information in order to do its job. And when you have a function that needs information to do its job, the way you give it that information, we call it passing in the information to the function. The way you give it that information is you put open and close parentheses right after the instruction. You don't put a space and then the open and close parentheses. You put it immediately after, and this is true in a lot of different programming languages. So inside the open and close parentheses, you provide the information needed by the function. In this case, it's text data, text information. Now, I'm going to take you through something very slowly. I'd like you to pay very close attention here because I'm going to teach you to think like a computer programmer. Computer programmers often think the way computers themselves think. There's a couple fundamentals about how a computer thinks. By the way, computers can't think. They're not alive. But they operate in a very specific way. Here's the first thing. They can only do one thing at a time. And two, they have to be told exactly what to do ahead of time, or they can't take any action. They can't just figure out what to do because it seems logical. That's what humans do. Computers can't do that. So I'm going to show you what happens when we take this instruction right here, this one single line, and we feed it into the computer, and we say, hey, this is some JavaScript. Please process that JavaScript and do what it tells you to. The computer does the following. Watch this. Watch where my cursor is. This is the important thing. You see my cursor there. This is what the computer's actually going to do. It's going to read the first character, A, and it's going to check to see if one of two things is true. First, it's going to say, is this character I'm looking at, just the A, is this one of the built-in instructions in JavaScript? And if it is, great. That built-in instruction has already been defined and the computer knows what to do. If it's not a built-in instruction, and it's not, by the way, the letter A is not a built-in instruction in JavaScript. If it's not, the very next thing that the computer is going to do is going to go, okay, so it's not a built-in instruction. Is it a variable? Somewhere in this program, has someone made a variable called A? Well, we haven't even gotten to variables. There are no variables in this program. So the computer goes, oh, well, it's not an instruction. It's not a variable. Fine, I'll keep reading. And now it reads two characters, AL. And it does the exact same thing. It says, is this a variable? No, it's not. Is this an instruction in JavaScript? No, it's not. All right, let me get the third one. Same thing, not a variable, not an instruction. And it keeps doing this one character at a time until it's looking at all 5 characters here. It says, is this an instruction in JavaScript? Bingo, it is. And since what to do with this instruction has already been put into the computer, now the computer knows what to do. And here's what it does. It says, okay, if I have this instruction called alert, the next thing that I should expect is I need to be given some information. And I'm going to find that information in between 2 parentheses. So it starts reading forward. It reads the next character. It says, is this an open parentheses? Yes, it is. Okay, good. All right, that's what I expected. Now, if it instead was a space, it would have a problem. It would go, that's not what I expected. And it would stop. The computer would stop and go, I'm lost. Because again, computers can only do what they've been told to. They can't just figure it out. They can't go, well, we kind of knew what Erik meant, so we'll just keep on looking. They can't do that. They can only do what they're told to. So it reads that next character after alert and goes, okay, good. I found an open parentheses. Well, what I need to do is I need to find the end of this information. I need to go keep forward. Is that an end parentheses? No. Is that? No. So it goes, keeps going forward, and none of these are end parentheses. And then it finds this. It goes, oh, good. That's an end parentheses. All right, that's what I expected. Now, let me go back right after that first parentheses. This is literally what the computer is doing, except it does it super fast. And so it goes, okay, so what's supposed to be inside the parentheses is some text information. Well, I expect text information to be inside of quotes. Is this first character a quote? Yes, it is. Okay, good. Well, I'm looking for what's inside the quotes. So I better read forward and find another quote. Oh, good. All right. Well, now it'll go back and it'll say, I'm going to grab everything inside the quotes. Okay, I've got that. And now it can actually perform the alert instruction. And only then will the computer make this thing pop up on the screen. Now, I know that might have seemed like really slow, methodical, and boring. But guess what? Computers are two of those things. They're methodical and they're boring. Now, they aren't slow, though. They're very, very fast. See, you click on run, boom, it instantly appears. The computer did everything I described in like 5 minutes and did it in a few milliseconds, which is kind of cool. But that's all it's doing. So if you can start to realize the computers only do one thing at a time, and they can only do what they've been programmed to do ahead of time, that's huge in confronting programming. All right, good. So we've got our first instruction. We've got an alert. Now we're going to do a lot of alerts. So I want you to do one thing. I want you to go right here, and before the hello world, I want you to type 1 colon and a space, just so that later on when we have a bunch of alerts popping up, we can track which one is happening in which order. Now, you made a change, so let's run our code, make sure it works. Now it says 1 hello world. All right. Let's move on to variables. We're going to make a variable, so go to the end of the line here of that instruction, hit enter. Let's make a variable. Now, there's a few different ways in JavaScript to make variables. We're going to choose one that's pretty universal. It's just a JavaScript instruction, which is var. And then hit a space. And now you need a name for the variable. Well, we're going to keep track of what's on these cards that we're turning over, right? So let's say we have a variable called card, C-A-R-D, 1. That's card 1, right? Now, hit a space, and then the equal symbol, and then do a quote, and do heart, spell heart, and then do a semicolon. I'll give you a moment to get caught up. And now let's talk about what's happening in this instruction. Because again, these are some fundamentals that if you understand them pretty crisply and strongly, that'll help you figure out why your program isn't working the right way or how to learn a new programming language. It's actually pretty important. So there are 2 things happening in this instruction. The first one happens with this section of the instruction. And here's what happens specifically. When the computer receives this part of the instruction, it says, oh, I need to create a variable. And the variable is called card1. Now, let's dive a little deeper. What really happens is, you know those memory devices I talked about earlier? They call them RAM. One of the locations, again, there could be 4 billion locations to store information on this little teeny device, which blows my mind. One of the locations is chosen, and it's given a name, and that name is card1. Now, there's no information stored in that location yet, but that location has been identified and given a unique name, and that name is card1. That process, the process that's being completed by these highlighted instructions, that process is called declaring a variable. You've made the variable. You haven't put in any information in the variable, but you've declared it. Now, this is where we say, good, now put some information in that location. And the information we're putting is some text information. We're putting the text H-E-A-R-T. Think of it like this. These memory locations in these devices, you can think of them like a billion individual buckets, and the bucket can hold something inside, right? On the outside of the bucket is a unique name. No other bucket has that name. And on the inside of it is the information you want to keep track of. So this first part, where we declare the variable, that's just choosing the bucket and putting the name on the outside. This part, which we call assigning a value to the variable, that's where we put something inside the bucket that we're going to keep track of. So two things happen right here. One final little bit of nerdy nuance is that this little symbol here that's equals, it's called an operator. The operator operates the computer. It tells the computer to do a specific thing. In this case, it's a special kind of operator called an assignment operator. This is the operator that can assign a value, the value, to a variable. That's what an assignment operator does. So there's some fundamentals of working with variables, but we haven't really used it yet though. Why don't we use this variable and we'll put it in an alert. Let's make another alert. Alert. Do your open close parentheses. And now go inside those parentheses. Oh, go to the end and do the semicolon. By the way, the semicolon is what tells the computer that the current JavaScript instruction is done. That's the end of this current instruction. Go back inside these parentheses, and now we want to use this variable. I want to use it by saying, hey, the card you turned over is, and then we'll use the variable. So do a quote right here, make it double, go back inside and say, the card you turned over is, do a colon, and then a space. Now, right now, let's go and run our program. Make sure it works. We haven't used the variable yet. We're about to. Run it. Well, there's our first alert from this instruction right here. Click OK. And there's the second one. All it says is the card you turned over is. All right, well, now let's use our variable. Go right here. Look at my cursor. Go right after that double quote. Hit a space and then the plus symbol. And now the name of our variable, card1. Now hit run. There's our first alert. Hey, there's our second one. Okay, fine. I mentioned earlier when we were talking about the 5 fundamental elements of a computer program that we're trying to keep track of data that can change. Well, let's change the data. Hit enter. And now let's change card 1 from a heart to a club. To change the value, all you do is type out the name of the variable, card1, and then that assignment operator. And here inside the double quotes, we'll make it a club. Make sure you put a semicolon at the end. Now, don't run your code. Please don't run your code. I have a question. I would like you to put your answers into chat. Nobody else can see them. What do you think the second alert is going to say? Drop it into chat. When we run this and that second alert pops up, not the first one that says hello world, but the second one, what is it going to say? Good job, Krishna. And that's not right, and I'll show you why. Same thing, Jogi, that's not right. Let's run our code, and we'll explain why it works that way. So there's the first one, hello world. We expected that. It says the card you turned over is heart. Now, some of you, and there's no shame in this at all, some of you guessed that it was going to say club. Here's why I didn't. Remember I said earlier that I'm going to teach you how to think like a computer programmer or a developer? And that really, the beginning of that is to start thinking like a computer. A computer executes these instructions in order from top to bottom. So let's talk about this specifically. The first instruction is this, and we see how that works. It pops up an alert, there's no problem. The second instruction makes a variable called card1, and it gives it a value of heart. So when we run this instruction right here, the current value of the variable called card1 is the only thing the computer knows. The computer literally has no idea that on the very next line, you're about to change that value. It has no idea because the computer's not going to read ahead and see what you're going to do next. It's only going to do what you tell it to. And what you told it to is, hey, give me this text that says the card you turned over is, and then give me the current value of the variable called card1. That's all the computer knows. And again, a computer's not human, so it's not going to go to the next instruction and go, hey, wait a minute, you changed it. That's not how computers work. So that's why it says card1. But we did now, after that, change the value of the variable called card1. Let's use it. Let's do another alert. Oh, wait, we're supposed to number our alerts. Go to this second alert right here, right after the double quotes, and go 2: Again, we're just keeping track to make it easier when we have a bunch of alerts that happen. Good job, Anne. I see you saw that. That's awesome. All right. So we changed the value of the variable card1 to club. Let's use it. Alert. There's your double quotes and a semicolon. Go back and do double quotes. And here we're going to say, we can call it number 3, right? The card you turned over is, and let's do the same thing, plus card1. I'll leave it there for you to get caught up. Let's run our code. There's the first one. We expected that. There's the second one. And at the time that we did this, the value of card1 was still heart from the immediate prior instruction. Now let's click OK. And now it says, hey, number 3, the card you turned over is club, because we changed the value. So it's just to demonstrate literally what we said on the 5 elements slide. It's true. A variable is meant to keep track of information that can change while the program is running. And we changed the information and we kept track of it in a variable. All right. Now let's move on. Go to the very end and hit enter again. Give yourselves a little more room. And by the way, you can have space in between instructions if you want to. Okay, that's just some random letters. The space doesn't do anything. It makes things a little more readable, but we're not going to do that. We'll just start typing right after that third alert. So let's talk about control and branching. So here's what I want to set up is I want to be able to compare 2 cards and see if they're equal. And if they are equal, then we're going to let the user know, hey, you got a match. And if they're not equal, we're going to say, sorry, that wasn't a match. That seems like some pretty fundamental logic we would need in a matching game program, right? So in order to do that, we need a second card. So let's make a new variable for our card 2. So var card2, and let's make it equal to club. I'll let you get caught up. And now I want to compare card 1 to card 2. More precisely, I want to compare the values stored in those variables. And if they're equal, then we know we got a match. And let's tell the user, hey, you got a match. The way you do that in JavaScript is with a control instruction called if. So type if, and then immediately do an open and close parentheses. And then hit space, hit a curly bracket, enter twice, another curly bracket. Now, this isn't complete. We're going to fill in some stuff. I'm showing you a structure for your code that's really good to understand. So here's how this works. Put your cursor right there inside the open and closed parentheses. We're about to type something in here. More precisely, we're about to give some information that this if instruction can look at, and it can make a decision on. Remember, if is really special. It's a control instruction. We're about to control what happens in our program. We're about to say, hey, listen, you've got a couple different things you can do. You could pop up an alert that says, hey, you got a match. Or you can pop up an alert that says, sorry, no match. You have to control which one of those two things happens. And the way you control two or more things happening, which one of two or more things happens, is with a control instruction. If is a control instruction. So what we need to do inside this parentheses is give it the information it needs to evaluate or look at. Specifically, we need to put something in here that when the computer looks at it, and this is critical, we need to give it information that a computer can look at, and it can decide whether the information in there is 100% true or completely false. Not mostly true, mostly false. No, it's got to be either 100% true or 100% false. Computers don't deal with ambiguity. They don't deal with ish. They don't deal with kind of. You've got to give them some information that it can look at, and it can determine whether or not that information is 100% true or 100% false. That's it. So that's what we're about to put inside this parentheses. They call that thing a condition, by the way. Check the condition. Is the condition true or false? The condition we're going to look at is, hey, you know these two variables, card1 and card2? Do they have the same value right now? That's the information we're going to give it. Here's these two variables. Please compare them and tell me whether or not they're equal to each other. And the way you do that, go back inside those parentheses and type out card1 space equals space card2. And by the way, there's two equal signs there. And we're going to start in understanding this with that symbol that I have highlighted. Remember that I said earlier there was an operator up here which is a single equals? And I said this operator is called an assignment operator. It tells the computer, hey, assign a value to a variable. Well, this is an operator too. These two symbols being right next to each other is an operator. And what it says to the computer is, compare the information on either side of this symbol to see whether or not the information is equal on both sides. It's called a comparison operator. And so we're going to compare the value of card1 and the value of card2. Well, let me ask you this. Drop it in chat. When we get to this point in the program, is the value of card1 the same as the value of card2? It absolutely is, Mark. It absolutely is. Let's follow this along. First, we make card1 and it's equal to heart. But then we change card1 and make it equal to club. And when we make card2, we also make equal to club. So at the moment we're checking this condition, the value of card1 is club, and the value of card2 is club. These two things are equal. Awesome. Good job, Mark. So we're still not done. We have not yet told the computer what to do. Thanks, Ann. We have not yet told the computer what to do if the two values are equal. In other words, we haven't told the computer what to do if the condition inside these parentheses is true. The way you do that in JavaScript is right after the control instruction. This is the control instruction right here. You give it what to do if the condition is true, and you put it inside of two curly braces. That's why I had you write these. So right inside here, we're going to put, what do we do if it's true? Now, for readability's sake, I want you to put your cursor right there where I have mine and just hit the tab once. We're going to start writing over a little bit. It just makes it easier to read the code. It doesn't change the way it works at all. It just makes it easier to read it as a human being. So what do we want to do? Well, we want to pop up an alert that says, you got a match. Let's do that. Alert, open, close parentheses, and semicolon. Go back inside and go, double quotes, and go, you got a match. Let's run this. There's number 1. We expected that. Here's number 2. Yeah, the card you turned over, it's a heart right now. Yeah, card 1 is a heart. Number 3, card you turned over is a club. Yeah, we expected that. Okay, good. And now here, you got a match. We went through this instruction right here, found that card 1 was club, card 2 was club, and so we said, you got a match. If you didn't get that response, if your program didn't work the way mine did, look very closely at this text and make sure you typed it exactly the way I did. But now I have a problem. Watch this. I'm going to show you another special thing you can do in programs. I want you to watch very closely. Look where I put my cursor. It's right there at the beginning of this line right here. There's my cursor. Okay. I want you to do // right there. Notice that the color changed. That's just for us to be able to read the code a little more easily. But here's what we did is we took that line and we turned it into a comment. You can write comments in your code. They're not instructions. They won't tell the computer to do anything. They're purely for human beings to understand what's going on. And so since I turned that instruction into a comment, the computer will not execute it. The computer utterly ignores it. So we're going to make card 1 equal to heart right here. We're not going to do this instruction. So card 1's still going to be a heart. And then when we get down here and do the comparison, card 1 is a heart, while card 2 is a club. Let's run this program. There's number 1, hello world. We expect that. There's number 2, the card you turned over is heart. We expected that because we made it heart. Number 3, oh, the card you turned over, yep, it's still a heart. But now we have a problem. This is not true anymore. So hit enter, and the program's over. Nothing happened. And the reason it didn't happen is because the computer is not going to do anything unless it's told to. And we didn't tell the computer what to do if this condition right here was false. We have to tell it what to do. So here's how you do that. Go to the very end of our little program here and hit enter. And now use another special JavaScript instruction called else. Hit a space, the curly bracket, enter twice, and another curly bracket. Else is another control instruction. It's only used after an if control instruction. And it's used to say, hey, Mr. Computer, here's what to do if the condition is false. We told you what to do if the condition was true. It's right here inside these curly brackets. Now let's show you what to do if the condition is false. It'll be in these curly brackets. So let's put what to do. Again, hit tab once just to make the code a little more readable. We'll do an alert. And say, sorry, no match. I'll let you get caught up. Okay, run. There's number 1. We expect that, hello world. There's number 2. Yep, the card is heart because we said it there. Number 3, the card is still heart. Number 4, sorry, no match. So now we told it what to do. That's control and branching. So again, we have variables. We have control and branching right here. And let's go on to the final thing we're going to cover in coding, which is subprograms. So step away from the code for a second. Let's just talk about this for a second. If you're going to build one of these matching games, you're going to need to compare 2 cards over and over and over and over again. Every single time the person turns over 2 cards, you have to do this comparison in your program to see whether or not the 2 cards are equal. Now, I don't know about you, but I don't want to have to type this right here over and over again for every possible turn the person can take. Let's say we allow them, 10 turns, 10 guesses. I don't want to have to write this code 10 times. Compare card 1 to card 2. Okay. Nope, not a match. All right. Select 2 more cards. All right. Compare card 1 to card 2. I don't want to type all that out. So we can take this and we can make a subprogram that has those instructions in it. And then every time we need to compare cards, we can just use 1 line of code to call that subprogram. And we're going to build one of those. In JavaScript, these subprograms are called functions. There's lots of different programming languages, but most of them have this concept of a subprogram. They might call it different things. It might be a subprogram. It might be a subroutine. It might be a function. It might be a method. They're all the same basic concept, though. And here's what that concept is. Let's take the logic that we built right here. The logic is pretty clear. Take 2 cards, compare them for equality, and do 2 different things, do 1 of 2 different things based on whether they're equal. That's the logic involved. We want to put that logic inside a little box that's our function. So let's make a function, go down to the bottom here. And in JavaScript, you can do that by using the word function. And then hit a space. We have to have a name for this function. We need some way to refer to it. So we're going to call it compare. I like compare. Now, this part's important. Don't hit space. Immediately after this, do an open close parentheses, a space, and then you're going to see this pattern a lot. Open curly brace, enter a couple times, close curly brace. This is the format for how you build a function. You have to use the function word. You have to give a name to the function. Inside the parentheses, this is where you describe whether or not this function is going to need some information in order to do its job. When you pass information into a function for it to work with, that information is called arguments. You're passing in an argument. It's an old math term from a long time ago, but that's when you pass something into a function here, they call them arguments. Okay? All right. What arguments do we need? Well, we need 2 cards. So we're going to say we need variables that will stand in for our cards. I'm going to call this first underscore card, and do a comma, and do second underscore card. That's what's going to, when I use this function, that's what it needs. It needs the first card and the second card. Okay, good. All right. And now I need, what's the logic? What am I going to do? When I run this, what am I going to do? Well, again, hit tab just for readability. And we're just going to compare the value of those 2 variables. We have a variable called first card. We have a variable called second card. Inside here, we're going to compare them. So you do if, space, open curly brace, and then the closed curly brace. We're going to set up an if instruction here. And let's compare first card to second card. If first, make sure you spell it exactly the same way, underscore card, double equals, second, underscore card. Okay, that's the comparison we want. We have these 2 variables. We know that that's the right way to compare the values because we used it earlier. And now let's go down inside the curly brackets and go, well, what are we going to do? Well, we're going to do an alert. And you know what? I'm going to make it real simple. Just go match. I like that. Match. Okay. But now go down to the end of that. We need to provide what to do if there's no match. So we do the else. Do your open curly brace, your closed curly brace. Go inside there again, tab over just for readability, right? And we need an alert here that says, sorry, and it's a sad face. Sorry. Okay, good. So I want you to look at the part I've highlighted here. This is a function. It's a reusable chunk of code. We have a name for it. The name is called compare. From this point down in our program, from this point forward in our program, anytime we want to use this logic of comparing the value of two cards, all we have to do is call on this function and give it two cards. And it'll tell us whether or not they're equal. That's kind of cool. Now, before you run this, here's my question. I'm going to be very precise about this question. When we run our program, what's the final alert that pops up going to say? Take your time, look through the program, and see if you can figure out the last alert to appear. What is that alert going to say? Exactly. Good job, Charisna. That's exactly right. Mohammed, that's not right. Well, Mohammed, that's not complete. So, yep, that's right. You're right, Kurt. That's exactly right. Othman, that's wrong. That's exactly right. Okay, so let's run it. Pay close attention and see what's the final alert that comes up. Run it. Hello world, we expected that. Click OK. Number 2, the card you turned over is heart. Yeah, we expected that. Number 3, the card you turned over is, yeah, it's still a heart. And then it says, sorry, no match. Now watch this. I'm going to click it again. That's it. Sorry, no match was the last thing. Now, some of you thought that it might say this. Sorry with the sad face. And I want to clarify exactly why. You're right, Othman. This part's really important. And if you grasp this, it makes writing your programs and reading other people's programs so much easier. And if you don't, it makes things very confusing. So I'm going to highlight this function again. Look at all the text I've highlighted. This is really important. What this is, where it's called, declaring a function, right? It's a definition for potential work that could occur in the future. You're telling your program, hey, don't do this right now. I'm not telling you to do this work right now. I'm telling you, if you want this work done later, here's how you ask for the work to be done. You say later, hey, run this function called compare, and here's some information to use in the function. That's all that this is saying. It's saying, here's some potential work that you could have be performed in your computer program later on if you want to. But you have to explicitly ask for it to be done. And we have not asked for it to be done. And Mark has another point. There's no variable called first card anywhere. There's no variable called second card anywhere. So how do we use this function? Well, like this. Go to the bottom and hit enter. And let's just call the function by typing out its name. And we are going to do the 2 parentheses and a semicolon. And then right inside here, we need to give it some information. Now you can give it information a bunch of different ways. Watch this. Here's the information we're going to give it first. Do a quote, spade, comma, quote, spade. And run the program. There's the hello world. There's the alert 2. There's the alert 3. Here comes the alert from our if. That's the sorry, no match. Watch this one. We're comparing a spade to a spade. We hit OK, and it says match. This alert that you see on the screen right here, it says match, happened because we called the compare function and we gave it these 2 strings, these 2 pieces of text. And they are identical, aren't they? But you can do it another way. Go down here, hit enter again. Let's run compare again. This time, let's give it some variables we do have. We have a card1 variable. Let's give it that. Card1 and card2. Now run your program. There's the number 1, hello world. There's number 2. There's number 3. There's the one from this if else. Here's the one from passing in spade and spade. And now we're about to see what happens when we pass in the value of card1 and card2. What are the values of card1 and card2 right now? Well, card1 became heart, and we didn't change it, so it's still heart. Card2 is club, and we didn't change it. So we're passing in a value of heart and a value of club. Hit enter, and it says sorry. And that's how it works. Well, we can change. We've always pretended, we pretended so far that card1 variable is the first one they turned over, and card2 is the second one. So let's change those values. Let's say card1 equals diamond. And then card2 equals club. This just reflects the fact that the user, the player, flipped over 2 more cards, and now they are different values. And again, all we have to do to compare them is use our pre-built function compare and pass in card1 and card2, like that. And it will compare diamond to club. Let's run it. I have an error somewhere. Oh, thank you. There's my error. Good catch. There's number 1. There's number 2. There's number 3. This is from our if right here. It's about to happen. Okay. This is from comparing a spade to a spade. Yeah. This one's from comparing card1 and card2, but they are equal to heart and club. So it should say that there's no match. Good. This is, well, they made 2 choices. They're comparing to a diamond to a club, and it says sorry. So over and over again, every single time the player makes 2 new choices, we can compare those choices, and we can do it with 1 line of code right here. Now, one final benefit to that. Let's say that we wanted to change the message that we showed people when they made a match. Let's say this was too aggressive with all caps. We can go back and change it and make it lowercase. And now every single time we call the compare function, it uses this new changed output. Maybe we use compare 20 times in our program. And so now you're able to make a change in one place. Inside the place where you created the function, you made a change in one place, and that change is reflected everywhere else in your program that you made that change. It makes it a lot easier to maintain and build your programs. All right. Now, take a look at this link I'm going to drop into chat. And what you should see is this code that you see on my screen. Do you guys see that? Give me a yes or no if that worked in chat. Good, excellent. Now, copy all of it. Like click somewhere in here, do a Control A, a Control C to copy all of it. Go back to your editor, and then do a Control A, delete everything that we already made, do a Control V, and paste in that new code. This is the code for the actual match game. And I want you to run it. And then we're going to look around inside the code. So run it and use it. Play the game. Spade and club, diamond, and a heart. Spade, club, diamond. Good. I won. I wonder how you can lose. How many turns you get. Oh, attempts remaining is down here. Okay. Woo! I can't win. Game over. You lose. Play again? Sure. Okay. All right. Where to paste it to? No, in the same thing. You just literally erase everything you have and then paste it in here in your code editor. Now, let's review this code a little bit. Now, all this stuff here, this is all HTML and CSS. We're not going to teach you all that tonight. Scroll down until you find where it says script. All of this is JavaScript from here on down. And it's got some comments in there to help you understand what's happening. It's got some variables. There's a couple ways of making variables, const and let. Those are just different JavaScript things. So you're making variables, and you can tell, look, that's an assignment operator. We're assigning values to variables. Oh, look, here's a function. We know about functions. It's set up as potential future behavior. Anthony, the place to get that code is in this link that I'm posting again in the chat. There's where to get that code. And then here's another function called flip a card. Okay, yeah. And look, function to check if the flipped cards are a match. Huh. So if the symbol is equal to the symbol, then disable the cards because you found a match. Otherwise, unflip them. So you can follow along with some of the logic in here. Now, again, there's a lot going on in this program. I understand that. But you'll at least hopefully be able to read through it and understand and recognize some of the things. The fact is that if you wanted to, you could take your time and read through every single line here and start studying online against that background of, well, there's only 5 elements of any computer program. I know that. I know how to make a variable. And I know how to do control and branching. I know how to make functions. Okay, you could start to understand how this computer program works. And Kurt asked a great question. Are you calling functions within functions? Absolutely we are. Right here in the function check for match, if the cards are equal, we call another function called disable cards. Look, it's right down here. You can call a function from within a function, which is kind of cool. Oh, it's a really good question, Kurt. So there we go. Again, there's a lot going on here. Even though this program is only, well, it starts here and it goes down 10, 20, 30, 40, 50. This is maybe 70, 80, 100 lines long. Maybe this program is 100 to 120 lines long. That's all there is. Okay? But this program accomplishes playing this game. And you can figure out how all of this works given some time. Now, if you do one of our boot camps, you'll understand JavaScript all the way down to the core and be able to program stuff like this and a whole lot more. All right, let me stop sharing on this. Switch over and go into quick Q&A, although I think we've got things pretty well. Let me look at the chat. Are there any? Okay, what are the const variable symbols for? The variable symbols in that were for what gets displayed on the card. Is it a symbol of a heart, a diamond, a club, or a spade? You're welcome, Kai. Absolutely. All right. And stick around. We got a free gift coming for you. Okay. I want to talk a little bit about the boot camps we offer. If, by the way, if you enjoyed doing this at all, anything about this, like about the logic involved, you know, the flow of a program, be able to control the path of execution, creating these, you know, chunks of code that you can call on over and over again, even if it was challenging at various points. If you enjoyed it, then you owe it to yourself to find out a little bit more about who we are and what we do. We have 12 online boot camps. They cover a wide range of technology subjects. You can see them here, anywhere from artificial intelligence, computer programming, web development, cybersecurity, design, data science, video game development, mobile app development. In fact, we have more certification programs, more boot camps than any other coding boot camp on earth. Okay, and this part's important. By the way, it's just a minute until I'll give you a way to get the free gift, which I think you're going to like a lot. Okay, our boot camps are self-paced. You're not going to have to move in lockstep with every other student in your class. You move at your own pace. You set your own schedule. You can enroll 365 days a year, right? They're very flexible. The content is really well-rounded. It's in-depth. They're affordable, like we talked about before. All of these programs include job placement training and assistance. But most importantly, all of these programs are designed for absolute beginners. No technology knowledge or prior coding experience is required, so you don't have to be a nerd to get through these boot camps. We consistently land on every major best coding boot camp list, and in fact, about 2 weeks ago, we were ranked in the top 31 boot camps in the world by Course Report, which is a phenomenal website. Our average review rating across all the major boot camp review websites is 4.8 out of 5 stars, and that's based on student and graduate feedback. So, and by the way, and yes, we do have payment options. I'll talk about that in a second. Why might you want to work in tech? It isn't for everybody, but some nice things about it. It has a really nice work-life balance, right? Supports work, remote work quite a lot. Okay, it's a really creative industry that you can take where you can take a lot of personal pride in your work. It's a stable industry that pays really well. The average wage across all industries in America is about $58,000 a year right now. Okay, the average wage for a computer programmer is $120,000. Yeah, you have to get started and you have to move up the line, but as long as you keep abreast of changes and work hard, you get regular increases in pay. It's pretty cool. That said, there are barriers to doing a boot camp. It takes, for example, money, like thousands of dollars to get through a boot camp, right? At the school, the Tech Academy, we have multiple financing options. This is what one of you asked about earlier. We have, first of all, a huge upfront discount, right? But we also have lots of monthly payment options for whatever credit situation you have. Finally, I firmly believe that getting through a Tech Academy bootcamp is genuinely an investment in yourself. You're giving yourself a set of skills that are highly in demand, have been for decades, and will be for decades. And it's stuff that people want to pay well for, which is pretty cool, okay? Finally, another barrier to getting through a bootcamp is time. There's a lot of material to cover, right? Some schools, some boot camps solve this by making you go through school in a cohort where everybody starts at the same day and moves through the class material at the same pace. I can't stand that method of learning. I couldn't stand it when I was in high school. We don't do it that way, right? You choose your study schedule. It's a fully online program, part-time studies allowed, so you can fit it in around other things in your life, like a job or going to school, okay? Ryan, there are options like that. You should, we're going to give you an email address to send in stuff in. Tell them that you want to talk to me personally about that, okay? He asked about, is there access to one-on-one tutoring options? So put that in the email that you send in a little bit here, Ryan, okay? The last thing I want to talk about in terms of like barriers to getting through a boot camp is that you do have to have at least some technical interest or ability. The fact that you showed up on a Friday night to attend a free coding class tells me there might be some interest there. On the ability point, it's just a question. You don't have to answer in chat if you don't want to, okay? But have you ever been trying to study coding, computer programming, technology, and felt like you were stupid or felt like the stuff was way over your head? I just want to let you know that that's not a you problem. That's a technology educator problem. Some educators put together really hard to understand material without even realizing it. Why? Because they assume too much prior knowledge on the part of the student. They don't spend enough time putting in the fundamentals. And they start way too far down the line, and it makes it so hard to understand, and we lose really good people to tech that could learn the material and could have great careers. We don't do that. With our programs, you don't have to be a nerd. You don't have to have any technical background. We start you with the fundamentals. Yeah, you're absolutely right, Joey. There's so much ambiguity about things. We want to give you crisp, clear definitions. So I have a question. It's a broad question. Answer it in your head. I don't need to see anything in chat if you don't want to. Are you maybe working a dead-end job or a job where the ceiling on it is just never going to get you where you want to go? Maybe even you're unemployed, or maybe you want to work from home and the job you or career, the industry you're in will never allow you to work from home, or you want more time with your loved ones and the career you have won't ever accommodate that. In other words, is it time for a career change? And if it is, I want to put forth that the Tech Academy is the solution. We are career change experts. This is what we've been doing for over a decade, okay? In fact, that orange bridge you see there, we chose it on purpose because we're trying to be a route into tech for everyone. No matter where you're at when you approach the industry, approach the subject, we want to make it available for everyone. And like I said, we have over a decade of experience breaking people into tech. The average Tech Academy graduate makes around $30 an hour in their first job. That's $60,000 a year US, okay? And we have over 1,000 graduates working in tech, so it's not like we've just gotten a couple people through. Those first few years were wild, man. And they work everywhere, from small businesses, medium-sized businesses, huge companies like Uber or Facebook or Disney or Epic Games or Uber. We have our graduates everywhere. So as a reminder, we have open enrollment. You can start anytime. So I encourage you to enroll now. That said, January is pretty special. If you enroll this month, first of all, if you can figure out an upfront payment of the whole tuition, you get a full 50% off, which is huge. You're also not going to pay sales tax. We'll pay it for you. So there's no sales tax no matter where you live, okay? Oh, by the way, if you can pay upfront and you need a laptop, we'll send you a laptop that you can keep so you can do your studies on a laptop, okay? Again, for January enrollments, you're also going to get free books and our dictionary. We have coding books and a dictionary we wrote with crystal clear, simple definitions for thousands of tech terms. You get a free copy of that, okay? You also get a copy of our career planning guide that my co-founder and I put together. It basically assembles all the knowledge we've learned over a combined around 35 years in tech into how do you plan your first 3 years to be a really solid foundation for a career. What do you do at the 6-month mark, at the 18-month mark, at the 36-month mark? Every single thing step by step so you can plan your career. I've never seen anything like it, but we recognized there was a need for it, so we wrote it. Also, you get 3 free months of access to the Tech Academy Accelerator, which is a program that I run that, first of all, gives you access to hundreds of like free online educational videos and classes. But also, there's weekly workshops that we do that are way advanced, designed to accelerate your career, open video, open chat, back and forth dialogue. We build things, we break things, we get our hands dirty. It's a lot of fun, okay? And finally, unlimited job placement assistance. If you sign up in January, we've obligated ourselves that we will give you unlimited job placement assistance for as long as it takes for you to get your first job. You can work with our job placement professionals who are awesome, by the way, for as long as it takes. So your free gift is coming in a second. If you're interested in this at all, here's the link. You'll find it in chat. If you click on that to find out more, it's pretty straightforward. There's just a bunch of steps that tell you all about the school, right? There's videos, there's articles. You can even book a call with admissions. We want you to have as much information about who and what we are and how we teach as possible so you can figure out if it's the right fit for you. And this is how you do that, okay? So I'm going to give you a moment to grab that link and fill out that form if you like. And I need some water. Oh, Alvin, I'm the co-founder at the school. Alvin was asking what's my position at the Tech Academy. Anne asks, what's the average time to get a job after graduation? A lot of it depends on how aggressive you are. Most people take a couple months. But the people that like do it a lot faster than that, they actually follow our advice and recommendations in our job placement course, and they're just super aggressive about it. They network like crazy. They send out 5-10 resumes a day. Every time we have one of our job placement online like meetings where they can learn more about interview practice or that kind of stuff, they're always in there. Like if they, basically it's this way. If you approach getting a job as your full-time job, it happens pretty fast. It's just, it's a challenge to like work that hard just at getting the job. But the people that do that, it happens pretty quick for them. Some people just kind of peter out and we have to constantly encourage them, and it takes them longer. That's a good question, by the way. Ryan asks, is there guided instruction for learning V or Vim? Those are two text editors that a lot of people use for coding. Ryan, I'll say this. Not only is there no guided instruction for learning V or Vim, but you would have to hold a gun to my head and threaten the lives of me and my entire family for me to ever use V or Vim. So no, I can assure you there will never be any guidance on learning V or Vim. I don't know of a single code editor that I hate more than V or Vim. Have I made myself very clear? Okay, good, awesome. I use VS Code and I'm happy with it. Now, I know I'm being an opinionated jerk. Every time I try to use Vim or V, it just kicks my butt. And I'm a pretty smart dude. And I'm like, I don't understand what's happening here. So no, we don't have V or Vim instruction. So I appreciate that you like it though. All right, so let's move on. Since our graduates love us, referrals have always been one of the top enrollment sources for the school. And so years ago, we put in place a 5% commission payment for all enrollments that come from a referral. We pay the person that referred the student 5% of their tuition, okay? And that is not just for our students and graduates to take advantage of. It's there for you. So if you can think of somebody that like, man, they really should be talking to Erik or the folks at Tech Academy, just let us know in a moment when we give you an email you can use to get your free gift, and let us know who they are. We keep track of that stuff. There's people whose sole job it is to keep track of all this stuff at the school and make sure we pay out those commissions, okay? I mentioned books. We have 7 publications, 3 Learn Coding Basics in Hours books, a coding book for kids and young adults, the Technology Basics Dictionary. Ryan, yes, we have boot camps to focus on C++, absolutely. We have a coding book for kids and young adults, Technology Basics Dictionary, the Project Management Handbook, the book You Are Not Stupid, Computers and Technology Simplified. We've written a lot of books. Speaking of books, here's your free gift. It is our Intro to JavaScript book. This was recently completely revamped, rewritten. It's phenomenal, okay? If you want your own physical copy of this book, which I highly recommend this, it'll be sent out to your house. Just email us at that books@learncodinganywhere.com email address that Gracie just dropped into chat, and we'll send you your own physical copy. You have to give us a mailing address. And once in a while, we have people email us and say, yes, I want the JavaScript book, but they don't give us an address to send it to. So give us the address, we'll send it out, okay? And if you have any further questions, or there was someone who wanted to talk to me directly about this one-on-one thing or whatever, just put that information in your email, and anything that needs to go to me from those emails always gets forwarded to me, and I'll respond, okay? And referrals. If there's people you want to refer, drop that information in the email. I'll give you a second to grab that email and get an email started on it. Ooh, Alan asks, are there any courses for ethical hacking? Yeah, on our cybersecurity course, and our cybersecurity course is very good. You get done with that cyber security developer course, and you will be a top-notch ethical hacker. Like, yeah, you will know exactly. Look, with great power comes great responsibility. Our cybersecurity course shows you a whole lot of stuff about how to do a bunch of very bad things. Don't do the bad things. Use your powers for good. But yeah, absolutely. The cybersecurity bootcamp is really good if you want to be an ethical hacker. I love ethical hackers. Like, I love the work they do. So yeah, we do that. Courses for testing and QA. Not precisely. When you learn to become a software developer, you're going to learn about how to write tests and do QA. And usually what happens is people who already are programmers, developers, that want to move into QA, the QA folks grab them and say, yes, please. If I could have someone who's going to learn testing that already knows how to do software development, I would love that. In fact, there's a special role for it. It's called Software Development Engineer in Test, SDET. And they get paid really well, really well. So just do one of our software development classes, and you can move into QA really well. Krishna, I see the address. Please go and email that in to that books@learncodinganywhere.com. So it's not in chat, because we'll lose it in chat. But if you email it into books, yeah, thank you so much. I'll move this on. So again, here's that final link. Oh, this link is really cool. We use Linktree. It's got all of our socials. It's got links to our free educational YouTube video playlist, links to our books, our dictionary. Upcoming classes are all listed there, okay? Gracie just dropped that in chat. So if you want to become more involved or find out more about us, that Linktree is a great place to start. Alvin asks, is there any age restriction for the academy? Yeah, we can't teach anybody under 18. It's just the legal regulations here in America won't let us teach anyone under 18, which drives me up a wall. I will say this: if you have someone who's under 18, get them that kid's book on Python. It's really good. If you go to that link tree, you'll find it there. You'll find all of our books. But that coding book on Python for kids, I have many stories about kids from around like 9 to 15 years of age, that kind of sweet spot, that went through that book and learned to code and really loved it. So unfortunately, we can't formally enroll anybody who's under 18, but that's how they could get started. That's a good question. I'm watching chat, so if there's any other questions, let me know. I'll sit tight for a minute. Otherwise, I want to thank you all so much for attending. I loved all the questions today. It was really, really good. Absolutely. Thanks, Anthony. Thanks, Kurt. You too. Thank you, Ryan. Appreciate it. And if you're already coding, join that accelerator, man. That's so much fun. All right, I'm going to end it. Have a really good evening, and we'll see you in our next free class.